Okay, so for this video, we're going to look at a question like this. How many years would it take to have $100,000 in an account with 8% interest if you have $5,000 to invest right now? So this would be using our typical compounding interest formula, A equals P times 1 plus or minus R to the power of T. Then when we plug in our information, our principal or P amount would be 500 and our goal, or 5,000, excuse me, and our goal is to have $100,000. So our final amount is $100,000. Our interest rate is 8%, so we would have 1 plus 0.08 to the power of T. And as it stands right now, we look at this and we say, okay, I'm trying to solve for T, so maybe we divide by 5,000, just as a starting point. We're going to get 20 equals, and I'm going to combine like terms over here, 1.08 to the power of T. And then up until this point, if we're being honest, we're kind of stuck. If we're trying to solve for T and get T out of the exponent, we say, man, we can't divide by 1.08. We can't take the Tth root of both sides because T is in the exponent. So what we're going to look at today is how do we get something out of the exponent by itself, or how would we solve for something in the exponent? And we're going to do that, so we're going to come back to this problem. We're going to do this through the process of using what's called a logarithm. So the definition of a logarithm says that if b to the power of x equals y, then you can rewrite this in what's called logarithmic form or log form as log base b of y equals x. So our calculator is going to help us out here. We have a button on our calculator called log. It's if you have your TI Inspire, it's on the left side. It's right next to the number 1. You're going to have to press the control button, and you see that log. And what that's going to do is it's going to open up this general log. You're going to be able to input any base you want, and then any number. And then what that's going to do is that is going to be equal to whatever you have in your exponent. So what log form does is it rewrites the expression, maintains equality, but it solves for what's in the exponent. So we can use it to solve a question like this that looks really complicated. 5 to which power is 3,125? Well, if we put this in log form, we would have log with a base of 5. The base of the logarithm will always be the base of the exponent of 3,125 is equal to whatever is in our exponent, which in this case is x. So this is going to require calculator work. We're going to press Control Log on our TI Inspire, base of 5, 3,125. We press Enter, and we get a nice clean number, x is equal to 5. If you don't have a TI Inspire and you aren't able to do a custom log, maybe you have a TI 30, you can do what's called the change of base formula. So your calculator strokes could be this. Every calculator that's scientific has a log button. You can do log of 3,125 and divide it by log of 5. It will yield the same result. It's more clicking, but it does allow you to do these problems if you don't have a TI Inspire. I'm going to skip this one. It's going to be the same exact problem, but I'm going to jump back to our first problem that we looked at. How many years would it take if we had $5,000 and we wanted $100,000? We're now here to where we started. This now we can write in logarithmic form. Log with a base of 1.08 of 20 is equal to t. Then we can punch that into our calculator. Log 1.08 is my base of 20, and we get t is 38.93, so about 39 years, which is honestly pretty cool. In 39 years, you're going to get a free $95,000 if that's what you started with. So we're going to do a couple more of these, and we'll do a couple more application problems. So I just want to emphasize, in order to solve a equation, you first need to get your number to a power by itself. So if I'm looking at this one, 4 to the power of x minus 7 plus 6 equals 73. Before we jump right to log form, we need to get 4 to the power of x minus 7 by itself. So we can subtract 6 from both sides. and we get 4 to the power of x minus 7 is equal to 67. Now we're able to put this in log form. So log base 4 of 67 is equal to whatever is in our exponent. In this case, it's x minus 7. We're going to evaluate that left side. So log base 4 of 67, that's 3.033 is equal to x minus 7. Then we add 7 back over. X is equal to 10.033. It's just emphasizing you first need to get your something to a power all by itself. So you maybe need to subtract or divide by something out front. As far as e goes, what's going to happen is the exact same thing. If we have e to the power of x equals 20, we're going to put this in log form. So the base of our log would be e. So we would have log base e of 20 equals x. Now in math, what happens is we don't really like writing this because log is letters, e is letters. This looks like log. You'll never see that. This is also what's called the natural logarithm. The natural logarithm is a log with a base of e. So we honestly never write log base e. Instead, what we have is a button for the natural logarithm. It's right next to the log button on our TI Inspire. It's that ln button. So we never really write ln. We never really write log base e. We're gonna write ln of 20 equals x. But please note that ln is the exact same thing as a log base e. It's actually fewer keystrokes. X is equal to 2.99 in this case. Just really quick on ln, log base e, we'll always just write as ln. That's the natural log, kind of backwards there. This comes from German, so the ordering of the words is a little different, but natural log. Also a good time to mention, if you ever see a log with no base written, that is always implied log base 10. That's our common logarithm. Most basic calculators default to that common logarithm. That's because we count in base 10. But the main thing I want to talk about here is we don't ever write log base e. We would just write ln, but ln is log base e. So let's do a little more complicated one with e. We can do this one here. 3,000 times e to the power of 0.02 x is equal to 10,000. I'm going to start by dividing by 3,000. So e to the 0.02 x power would be equal to 10 over 3. This is me dividing by 3,000 on both sides. I just simplified my fraction. Now we can take the log with a base of e, which we just talked about is ln of 10 over 3. Is equal to 0.02x. You can evaluate the natural log of 10/3. That's totally fine to do that first. We're going to get 1.203. That's equal to 0.02x. Then we're going to multiply both sides divide both sides by 0.02. And we're going to get 60.20 for x. So the only other thing we're going to add today is what happens when we have an application situation. Something like this, like how we started today. So I'm going to do 2 more of these, and then you should be good to go for solving using logarithms. Your student loans amounted to $80,000 after you graduated, and your interest rate is 8%. Assuming you never pay down any amount on your loan because you just, forgot, how long will it take for the amount you owe to jump to $100,000, which obviously does not count any kind of late penalty? We're starting with $80,000. That's our P. Our final amount is $100,000. Our interest rate is 0.08, and we want to solve for time. Now, would we use PERT or would we use our standard compound interest? Well, I don't see the word continuous compounding, so we're not going to use PERT. We're going to go back to that first formula we saw. We're going to plug in everything. $100,000 equals $80,000 times 1.08 to the power of t. Divide 100,000 divided by 80. We're going to get 5 over 4, or we can just do 1.25 is equal to 1.08 to the t power. And now we are home free. We're just going to put this in log form. Log base 1.08 of 1.25 is equal to t. We put that into our calculator, and we get 2.90. So about 3 years. About 3 years for you to owe an extra $20,000. Absolutely brutal. Let's do this one. Let's have a retirement savings goal. Let's say we want, when we retire, to have $2 million. I normally do this as a class activity. We're going to get an interest rate of 8%. It's continuously compounding. And right now we think about how much money we have. Think about maybe how much money you get when you graduate. Let's just say we're starting with $15,000. That's a lot of money for an 18-year-old. But let's just say you put all of the money that you've ever earned, all of the money that you get for graduation, maybe a grandparent helps you out. Let's just say we have $15,000 today. If we put this into the account and did not touch it, how many years would it take to have $2 million? It might be fewer than you think. Let's find out. If we are using continuous compounding interest, we're going to be using PERT. So A equals P times E to the power of RT. We're going to plug in all of our information. Our final amount is $2 million. Our starting amount is $15,000 times E to the power of 0.08 T. Now we just want to solve this. Step one, we're going to take $2 million and divide by 15,000. We're going to get 400 over 3. You can round that, but I'm going to keep it as a fraction. From here, we need logs. The base of our logarithm is the base of our exponent. So our base of our logarithm is e. But we don't write log base e. We're going to write ln. The natural log of 400 over 3 is equal to 0.08 t. So we're going to take the natural log of 400 over 3. That's 4.89. And that's equal to 0.08 t. Then our last step, we'll divide that by 0.08, and we get 61.16. So, does it take a long time to make $2 million? Of course it does. But would you have it before you died? Probably. And imagine what would happen if you got 9%. Or imagine what would happen if you had $20,000. Or imagine if you could add more over time. Remember, this is a free $2 million effectively. You do just have to wait 60 years. So that's going to wrap it up for this video.